Go ahead, a few at the back.
So I'm a consumer of climate model data that has been downscaled to resolutions that are usable, in applications that I do in agriculture and economics. I'm curious. It seems to me, from my perspective, one of the ways forward would be, second-order impacts. So, like as Ken said, there's a lot of first-order research on what geoengineering means for the planet. The second-order stuff is what then that means for things that people care about sort of more directly. So I have a technical question. So first off, that's a broad comment that maybe is worth responding to. But the second question might be, what dangers are there in taking these and applying downscaling techniques to geoengineering as distinct from sort of regular CMF5 type stuff? And I ask that naively as a non-climate scientist.
Okay, so I think I'll try and repeat that. He's a user of downscale data and is interested in climate impacts and is interested in, is that issue of the climate impacts of solar geoengineering settled? Picking up perhaps on the question of Kate raised. And are there any interesting scientific challenges that are distinct in terms of the downscaling processes and how they may play out under solar geoengineering versus under climate change? Anyone like to go ahead?
So I would agree completely that research needs to be done. I think the only caveat that I would introduce is more or less the one that I introduced in my talk, which is climate change is effectively to first order, it's one thing. We're increasing greenhouse gases, what happens. So the only danger is in over-interpreting the results to say, we looked at this particular simulation, we saw this particular thing happen. That's important feedback back into the process of saying, well, maybe we should see if there's a better way around that. It's not sort of the be-all and end-all. That's the only caveat I can think of.
Any further comments on that? No. Okay, any other questions?
Okay, so my question, it's for Ken. When you say that sort of the science regarding solar engineering is settled, I mean, that's the message you could have. So, no. And probably, like you said, well, things have been done with one model that there could be some do that some experiments like geoengineering. But there are some things, some fundamental questions regarding the microphysics of solar engineering, for instance, that we don't know. Like, we don't know, for instance, if you take 5 climate models and you ask, what is the amount of SO2 that you have to inject to get the tier 2 biology in a tier 2 machine engineering? They will come up with ranges from 10 to 20 terabytes of SO2. Or even just if you say, well, how many models that will run with a fully coupled stratospheric and ocean model? Very, very little. So was your message that?
Okay. Let me just, I'll compact that a little bit. The challenge to Ken was, is the science really settled? And Daniela gave a nice list of some of the challenges in modeling stratospheric aerosol geoengineering.
Yeah, so let me just say that my goal is to be provocative, and if I was in a room full of people who thought there should be no solar geoengineering research, I would be here arguing for solar geoengineering research. And so, I think, the thrust of my remarks was meant to elicit responses like you, but I think it's not enough to say, oh, we need to do solar geoengineering research. I think what you did is a great example, saying, look, what we don't understand is this cloud microphysics or the aerosol microphysics in the stratosphere. And then this is why we need to know this. This is the benefit that would come from knowing this, and this is how we could go about learning about this, and this is more or less how much it would cost. And that sequence, which you sort of went through much of, is really what we need to be doing.
Okay, so any more questions from more junior people? Oh. So to the right of the man, no, to the right of you, there's someone who's a little bit more shy. So that's you. If you'd like to give a question.
Okay, so I agree with the previous question that there's still uncertainty, but there was also a comment. I forget who exactly made the comment, but that we need to go beyond modeling and do some experimental tests on geoengineering. I kind of see that as a
repeat that. So, question was, again, challenging Ken a little bit on his science is all done. Someone suggested we need to do some field experiments to try and address some of the processes that are not well understood. And she raises the concern that this is a part of a slippery slope towards deployment, perhaps, or much larger experiments. And also, what are the thoughts on the legal issues that this could raise?
This doesn't seem to separate. So I actually have two comments on that. One is my personal view is we actually have just barely gotten the first climate models running that, as Daniel mentioned, first times we've actually had stratospheric aerosol microphysics in the same model that's coupled to the ocean. So to me it seems a little bit premature to say, we're done with modeling, let's go do experiments. We don't know what experiments we need to do. We've not done any of the research that says, parameter X is this uncertain, and that range of uncertainty will substantially affect our outcomes and substantially affect our conclusions about whether this is a useful technology at all. And without doing that type of research, I have no idea what experiments we even need to do. The second comment that I would make relative to slippery slope, my personal perspective, and I'm happy to have somebody disagree with me on this, is that experiments are either going to be process scale, so very small, or they're essentially global, and I wouldn't call that an experiment, I would call that the first part of deployment. So to me, when I look at the landscape of possible future experiments, and we should have this conversation as a community of what they look like, but I actually don't see a slippery slope. I see an incredibly bright line of scale separation between essentially tiny stuff that's atmospheric research, that's not fundamentally different from a lot of atmospheric research we do today, and stuff that starts looking more like deployment.
I think, a central question is what is the degree of urgency of this research? Some years ago when I was testifying before a House subcommittee on ocean acidification research, one of the first questions I got was, well, why do we have to do this year? Can we do it next year? Because if a politician could not allocate money this year and push it on to the next Congress, they're happy to. And, so I think one question is if we thought that society would want to deploy a solar geoengineering scheme, say within the next decade, well then, we should have a giant crash research program that should involve outdoor experimentation. But if we think, this is something that somebody might want to deploy 50 years from now or 100 years from now, it takes on a whole different character, and then you say, do you want to take on the kind of public issues associated with outdoor research? So I think there's a real question of urgency.
I think it's probably worth pointing out that there is no one on the panel who is proposing doing field experiments in the near term, but there are people out there in the field. There's an experiment proposed at Harvard, or more than proposed, planned. There's a proposed experiment on marine cloud brightening at University of Washington, or there's ideas there. So is anyone else on the panel willing to put the case for field experiments in the near term?
Well, I can say something. I would say that field experiment is necessary, but I think that the ability to do field experiments, I think that we should not assume that knowledge generation is bad. And so that I think that geoengineering field experiments should be treated equally with any other kind of field experiment that involves an outdoor manipulation, and that the nature of the knowledge related to solar geoengineering, that knowledge should not be considered dangerous. So the idea that you're generating knowledge related to solar geoengineering should not be relevant to permitting a field experiment.
Can I make a quick comment?
Okay, go ahead.
Any process scale field experiment that would be useful for geoengineering would actually be extremely useful for climate modeling to predict the future climate. So maybe it's a case of bad trust, like you can generate fear or excitement if you say it's a field experiment for geoengineering, but actually you could as well say, well, it's a field experiment because we don't understand areas of
So-
we don't understand aerosol microphysics, and that's what you're asking.
No,
Let me just, repeat the comment there, that is there a problem with labeling here? There's experiments that could teach you a lot about aerosol cloud interactions and perhaps aerosol processes in the stratosphere, that if you didn't label them as geoengineering, you would be learning about these processes that are important in the climate more broadly.
And somebody should take the microphone away from me so I can talk more, but you know, I think a lot of people, I don't want to judge people's motivations, but I think a lot of people in the cloud aerosol interaction area want to kind of see a marine cloud brightening experiment because really they'd like to do an aerosol cloud interaction experiment and they don't think they can get the funding for it. And so, you know, one of the problems is there's just not enough funding for basic experimental research for climate science.
Okay, so if our more senior colleagues can hold their horses for just a few more minutes, I will then open it up. So if another more junior researcher, so you, the gentleman in the blue shirt.
Thanks, I'll try to fit that as well. For some of Ken's comments, the goal, at least for many people, I think, of solar geoengineering is to actually make something better, make the world better. So it's very nice to see measurement of how it affects actually human well-being and inequality more broadly. My question is there, paper, Catherine and Douglas, is there any, a discussion of the ways that we could look at variability of actual deployment of solar geoengineering, and then another talk about the actual impacts. Any ideas between the two of you on how much variability there would be on the impacts from different deployment circumstances? And I mean, that begs tons of questions about what we want. So, it's hard to know exactly if it's less, inequality. I like that. But anyway, just interested in if you've thought about those.
One quick clarifying thing. When you say variability, do you mean spatial or temporal?
I mean variability in the phase space of outcomes. The impact outcomes that you could get from the inputs sort of that were discussed as different latitudes. The full battery of input variability effects on the full.
I'll try and summarize that. So his initial comment was, I think it was heartening to see people focusing on something that might improve the situation of the world. And he was then asking, well, what's actually possible? What if you, in the ways in which you vary solar geoengineering, like how much room for maneuver is there? What range of outcomes are possible?
Yeah, I can say from the perspective of our experiment that in that experiment, we were applying the most basic kind of solar geoengineering ever, which was we applied a uniform shortwave forcing over the entire planet. So like the most basic kind of geoengineering experiment. So I think what the work by Doug and others shows is that that's not necessarily what you would need to or want to do. I mean, it might impact the inequality outcome in a negative way, actually, because, going into that work, my hypothesis was exactly that. It was because, a solar forcing would reduce the pull to a greater gradient, temperature gradient. That means you could make more countries that are closer to the optimal temperature, right? That actually didn't turn out to be what was primarily driving the effect, but you can imagine, if you then were to apply a forcing that is more optimal for high latitude countries or something, then yeah, the equality result might go away, but you might get overall better outcomes from a global perspective. Yeah, we just scratched the surface, starting to apply more.
Yeah,
Go ahead, Bill.
it's my sense that it's a great thing to be able to do that, but that we're not there yet. I don't think the climate models, it sounds like we have some people who are familiar with the CMF archives, but I don't think the climate models are at a point where they can, with any confidence, tell you what you want to know for impacts. Temperature is not really what you want to know, right? So you want to know precip, and you want to know extremes, and you want to know sea level. So when you talk about coupling model components, we don't have any models that can couple an ice sheet component currently with the climate with any sort of verifiable skill. Those are just emerging. It'll be very interesting to see how it progresses, but part of this discussion has to be when the models are at a point where we can actually identify what the climate response is going to be. And I just don't think we're there in the fields that matter.
And my point would be a little bit more naive and even to say when you layer sort of the findings from the first talk on top of countertop, you, like, as you said, you may actually get less of the things that you actually like in this thing. So what's good in one sense may maybe not as good in another.
That's a fair point.
Right, well, we've had most of our answers on the left-hand side of the stage, where I've got my left and right. So if people have questions directed more towards the right-hand side with our stratospheric aerosol processes, the ocean, and agriculture, be interested to hear those. And now I'm going to open it up to more senior folks if they want to ask questions. Please go ahead, in the scarf.
Yes. So I was really intrigued by the enhanced overturning in your results. I wonder, we don't really have like other kind of analogs for a state of the ocean with enhanced overturning going on and yet the ocean dissolution spinning up. So I was wondering if we could comment a little bit more on if we're doing some carbon cycle monitoring and also think a bit about the time scales of commitment because fundamentally, if you're just injecting something into the stratosphere, that's going to be gone in 5 years anyway. So depending on the state, you can recover. But if you're injecting something instead of the deep ocean, the recovery time scale becomes much longer. So I'd like to know, are there like obscure paleo analogs I'm not thinking about that we can talk about, or what's the carbon, people who do carbon modeling, like what is the implication of having a spun up AMOC with dissolution going on at the same time?
Okay, so I'll try and remember all that. So there was an interesting comment that John's work showed a novel response, which was a speeding up of the Atlantic overturning circulation, coupled with increased carbon being stored in the surface ocean and then transported down. I wanted to know if there were interesting paleo analogs to that, and something about what the long-term commitment issues would be of that carbon being sent to the deep ocean. And the dissolution. Sorry, I might have missed that part.
Well, I think you've hit on two subject areas that are really outside my area of expertise, both with regards to paleo and also the carbon cycle. What I would say is that at the root cause is the water cycle changing, and so that we do have good observations of the water cycle to some extent back through the eruption of Pinatubo, and that there are known biases in climate models in the water cycle. They rain too much, they drizzle too much, and as a prerequisite to having any confidence in something like the AMOC response, which is driven by surface salinity, we need to get the water cycle response correct. And I think that the question you pose really underscores the importance of doing better in climate models with the water cycle's responses to forcing and even its mean state. So that's where I would start with addressing your question.
Does someone want to talk about the long-term implication issues of these changes to the ocean? That's quite different from the aerosol timescale response. Ken's always willing.
Sorry. Yeah, sorry. We had a paper, I forget where it was, Science Advances, someplace like that, on even looking with carbon dioxide removal, that there's long-term deep ocean consequences both for putting heat and carbon into the deep ocean. And so it sounds that there could be similar long-term consequences for this. But with long cow, we did a study with not as good a model, admittedly, where, at least in that model, the ocean circulation and heat changes in a solar geoengineering case were less than in a high CO2 case without solar geoengineering. So although with the CO2, the solubility does go up and you would get more CO2 in the deep ocean. So, but your model was better than ours, so I'm more likely to trust that, but I'd probably trust neither of them.
Okay, so the gentleman just behind you.
I'm wondering about the feasibility or advisability of doing this work without collaboration with political economists. I'm an historian, so I'm not a scientist, but it seems to me that this model requires an impossible degree of political consensus. One nation chooses to do it, another nation does not. One nation turns
So the question was related to the challenge of addressing any of these issues without taking into account political economy, and considering the governance issues that be involved in managing cooperation on something that is global in scope. Maybe Kate would like to
Well, I'd
take
just
that.
say that there are a lot of political scientists and social scientists working on this topic now. They're just not at the American Geophysical Union meeting. It's definitely, I would say the social science is a little bit further behind the natural science, which is kind of natural because you needed to know a little bit about what the effects of doing something like this might be before you can start thinking about what the impacts are on human systems and how you might, respond to those impacts from a governance standpoint. But it's a very active area of research right now, and there's also a number of initiatives going on trying to figure out what governing this looks like with the problems you raised exactly in mind.
Maybe a quick contextualizing comment. I think it's maybe I'm a little off here, but I think it's probably about 50-50 in terms of papers that are natural science focused versus social science and humanities, but I could be corrected by someone.
I was just going to disagree with Kate and say this is actually one of the only fields where the social sciences actually might be ahead of the physical sciences, which is partly a budget question, partly that it's easier to get funding on the governance side than it is on the physical climate side. But fair enough, but...
Sandra, do you have
Yeah, I would have a follow-up question. So, what does somebody know, or do you know in which extent this topic is this is a topic in Poland at the moment at the UN Peace conference? I know David Keith is there, but what are the policymakers talking there about solar geoengineering, if they do at all?
I can tell you that it's being discussed, but I don't know exactly what the details are. So just for example, in May, I was briefing the UN Environment Program in Nairobi. Janos Pastor, who was former #2 for UN on climate change, has been quite active in international conversations, specifically on this issue.
A friend who's an oceanographer who was briefing congressional staffers yesterday, which is I think one of the advantages for having this meeting in Washington, got asked about solar geoengineering, even though she's a chemical and biological oceanographer. So it is on the radar of some political people.
Okay. Got a question towards the back there. Straight sharp.
If there's any consolation, we the scientific community has been in this place before. And I think as we approach on how we're handling the geoengineering issue, we need to remember the long and difficult problem we have as scientists around the world in explaining to the public the real threat of nuclear weapons and nuclear war, in which there is now an overwhelming consensus that even the few bizarre demagogues who inhabit this city still aren't talking about nuclear war as enough. It took a long time for that to happen. We had to get a lot of information out from the military, which was classified before the public, such as Glasgow and Nolan's famous work on the effects of nuclear weapons. But we're facing this problem, and in response to what was just raised by, I thank a colleague from the political science community, if we think we're going to start anything beyond testing, I think we have to think again. And we have to make sure that everything that we do is brought before the public and that there is full public disclosure. If we fail to do that, we may as well manage this project. We are facing a problem that is as difficult as educating the public about the dangers of nuclear war. And we need to take it with that level of seriousness. And that took about 35 or 40 years in the scientific community. Thank you very much for any comment, even from someone my age.
Okay, so I'll try and summarize that. He was drawing an analogy to the distribution of knowledge or spreading knowledge about the dangers of nuclear war. as it moved from an area that was purely under military control into the public domain, to make the public and policymakers aware of its risks. And he said there's some analogies here with solar geoengineering that it's going to take some time to get the public up to speed, and we've got to learn the lessons of the past. And made a final comment on the importance, or perhaps the necessity, of bringing the public into accepting this, or having the public accept it before you move ahead with deployment and testing. Does anyone want to respond? No? Okay, that's a comment, and I will pick another question on the right-hand side. So please, you, the woman here with the dark hair. Is that Jen? Can I not see you very well from here?
I guess I have a question for Kate. I just wonder whether we should use more culture to develop the econometric model to predict such an aggregate outcome as to how GDP would change with respect to geoengineering. Because I think the most basic presupposition of any econometric method is that the past has some value for predicting the future, and it really doesn't have that much capacity to capture knowledge. But like geoengineering is such a novel technique, and we have many things that we just don't know about in its consequences. And I'm just not sure whether like econometric models work really well for consideration of solar geoengineering.
Okay, so I'm trying to do a good job after I couldn't see you properly there. So Jen was asking whether econometric models are appropriate given they make quite crude assumptions, and what could we do to do better? Is this an issue where they just will not be applicable?
So yeah, I heard the question as sort of two parts, which is first, are econometric models worth anything? I mean, under any circumstances, was kind of what I heard the first question. And then the second question was, is there something special about geoengineering and applying those models? And those are kind of the two things that I've been contending with a lot in my work. And I would say, there do seem to be circumstances under which understanding response variability in the past can tell us something about what's going to happen in the future. And then there are times when they're not appropriate to use. I think that your second question I can answer a little better, which is that I don't see why we should put stock in what these models tell us for global warming, for greenhouse gas-driven climate change, and not solar geoengineering. I really can't see why. The assumptions that you have to make to apply those models under global warming scenarios are also, there's a bunch of caveats. One of the things that I didn't have time to talk about, here's one of the problems with these models, is that often when you do these analyses, you find that the effect of precipitation is insignificant. So, in the model that we applied, precipitation was insignificant. And when we did our projections, we did them with and without precipitation included, and including precipitation doesn't make a difference. And so you can get into a situation where you're reducing precipitation in the world by, 300% or something with, well, no. 99% with geoengineering, you're getting the same effect as if you reduced it by 10% or something. And so you think, oh, there's something fundamentally about using them for geoengineering that makes this inappropriate. But that's just not true, because if you look at sort of the correlations between temperature and precipitation, for example, the interannual variability in the past is not the same as the change going into the future, right? Like, because of physics over land in the past, a dry year is usually a warm year, and a wet year is usually a cool year because of moisture availability and the air conditioning effect of moisture but if you look at projections of both greenhouse gas warming and solar geoengineering, you know, some places are getting warmer and wetter, some places are getting warmer and drier, and there's things that are getting baked into these applications of the models because of fixed effects that mean that these things that were fixed before aren't fixed, and maybe precipitation is significant, but we don't have enough cross-sectional variation in the correlation structure to know that. And so I do, yeah, sorry. So I do think there are, that's just an example of where I think there's a big challenge to applying these models that tell us a lot about how the environment does matter to things that we care about empirically, we can see that. But applying those models to projections of the future, I think is problematic for both greenhouse gas driven climate change and geoengineering. And I have not been able to find a particular reason why we should believe the models in one instance and not believe them in the other. But I would love to hear someone who can make that argument.
Okay, maybe we've got time for a last couple short questions. You towards the front there.
Yeah, sure. As somebody on the observational side of things, in the spirit of some of Ken's questions and other comments, I was wondering what you guys would think if we were going to make investments in the observational side of infrastructure that could be mutually beneficial for constraining some uncertainties about geoengineering. What kinds of measurement efforts would you most like to see?
So which observations would you guys like to find out? Well, what observations would you like to see to best reduce uncertainties in solar geoengineering?
Monitor the next Pinatubo.
Anyone else want to add anything? No. Okay, I'll move on. We want to ask everybody. So you towards the back there in the middle.
Yes. Thank you. I had a question to Kate. So you argue, say, solar geoengineering can reduce the economic inequality. And probably like this model we can say that. But in reality, like if you want to, if you start using solar geoengineering, it could create like family effect, which is detrimental for economic inequality. Yes. So why not include a scenario to which if the increase like the solar geoengineering contamination, because it could be happen, and if you don't increasing the scenario of when the solar geoengineering suddenly stop, and when you argue say solar geoengineering can use reduce the income inequality, which sounds to me it's kind of like selling like economists say, oh, they're creating economic bubble, and suddenly like an economic recession happen, which will be detrimental for the vulnerable community. So.
Okay, I'll try and summarize that. I believe the comment was if solar geoengineering has given solar geoengineering has the potential to reduce income inequality in the scenario that you showed, you should also be factoring in the risk of termination shock, because if this stopped, thered be a sudden warming, and that probably wouldn't be good for income inequality.
Yes, I think we should consider the termination risk in the whole risk calculation involved in evaluating whether we think geoengineering might be something we want to do or not do. I mean, this is, the stuff that I presented is an idealized scenario, very idealized, obviously. I mean, cooling at the same rate as RCP 8.5. I don't know why you would do that. It was just for convenience sake. I think of the uncertainty around something like the termination effect being a little different from the kind of uncertainties we were trying to get at with this study. I mean, it's something that's very hard to put a probability on. And so, I mean, scenarios by their nature are sort of subjective things, but the termination effect is something you definitely need to consider. And I've heard different arguments for why it's more likely or less likely, but it's a well-established fact that if you geoengineer and then you don't reduce greenhouse gases, and then you stop geoengineering, you get very rapid rates of climate change.
Well, I think the termination shock is the perfect point to end on. So on behalf of Lily Gia and myself, Peter Irvin, the chairs, I'd like to thank you all.